Design of experiment is actually doing experiment in a production shop, actually running a production on a trial basis and noting down the results and then further doing calculations. Now, if there are more number of factors, then the experiments would be in a large number. Every factor getting applied at different level. So consider there's so many combinations happen if there are more number of factors. We cannot practically do experiments with all the factors at different varying level because of time and money. So in a design of experiment, we have less number of factors. Now, what do design of experiment do for us? Design of experiments tells us sensitivity of a factor, sensitivity of a X factor. Now, what is the sensitivity of a factor? Sensitivity of a factor is with a small change, how much change is going to reflect in a final Y factor, in an output Y factor. If there is a small change in a X factor giving a large change in a Y factor, sensitivity of that X factor is very high. We are going to find out this in design of experiment, that's all. Yeah, so we are moving ahead on this. Now, what we are going to see in the program is there before you. We are going to see a little math. Then further we will move ahead to factors, labels, responses, certain terms in design of experiment. We will be focusing our attention on a case studies. We will be seeing how this design of experiment becomes useful to you. We have few introduction in the beginning. Hinterman has pursued a PhD. Now he wants to do a further research. Yes, Mr. Karthikeyan, I believe. So we'll be doing that. Now, how to interpret the results we'll be doing here. We will also have a small introduction of Taguchi's implementation of DOE, as well few concepts like signal to noise ratios, etc., robust design concepts, etc., and then application. Now, design of experiment is a big tool. So we are going to do this because there are 2 days we are going to do this. Now, what in there in the design of experiment? First, we will have fundamentals. We will try to understand, we will try to know basic terms. CTQ. CTQ is critical to quality. CTQ is critical to quality. This is nothing but a Y factor. Now I will give you an example. Suppose there is a mobile phone. This mobile phone has got a dimension of a mobile phone that can be called as a CTQ. This mobile phone weight is a CTQ. This mobile phone's resolution is a CTQ. So CTQ is a particular characteristics of a product. It is a measurable characteristics of a product. Now, this CTQ is termed as a Y factor in our language. To achieve a particular CTQ on a product, you do what? You set certain manufacturing process and you set certain input parameters. These input parameters are called as CTP. CTP stands for critical to process. Now, nowadays, safety is also important. You have to follow safety norms. So there is a term called as CTS, critical to safety. Now, how do we deal with these X and Y factors? In what other names? X factors are called as input cost factors as well predictor factors. Y factors are also called as response factors. Predictor, response. You have to remember these terms. We are going to share all these slides to you for your reference. When you go back, please remember these terms because in an advanced level we are going to use these terms. You might have seen Minitab software. In a Minitab, these terms are indicated. Now look here, I have given one another example, X factors and Y factor. This example is done in a company called as Emerson. We did our implementation there. So in the example, there is a heat generated at a plug pin. This factor in a Y side we have had considered. We wanted to control this. We wanted to rather monitor this. So we identified X factors. We control these X factors, then we could monitor this particular Y factor. Now, in our design of experiment, exactly similar situation occurs. We have a particular Y factor, we have around 3 to 4 X factors. Y factor will always be one, only one. Right. Now look at this. There is a very important concept which you might have be using in your company always, called as a root cause analysis. Now, in a root cause analysis, in an advanced level, we use design of experiment. Now, we have many X factors. These X factors are generated how? By doing fishbone diagram, as I said you earlier, as well brainstorming. Before you do fishbone diagram, you have to brainstorm among yourself. In a brainstorming, you identify several X factors. Along with the brainstorming, there is an important tool called as NGT. NGT is a nominal group technique. NGT is a brainstorming method only. In NGT, what do we do? In NGT, we have a sequence for every participant. Every participant is given a chance in a sequence. They talk their ideas. All these ideas are accounted. There is nothing random. There is always a sequential flow for specifying, for giving your ideas. So nowadays NGT stands good in companies. Why? Because the person doesn't get suppressed. Now, I believe you must be using these tools, either one among them or all among them. I am going to give you a brief on these tools. Why? Because I presume you are, some of you may not know these tools, so I will tell you in brief. However, not in detail, I will brief you about these tools. However, you can interpret, you can intervene with me as and when you require. If you require more elaboration, you can please let me know. If you require to go ahead, you already know these tools, we will bypass. No issue. We will not remain very rigid. We will remain flexible for this particular delivery. Okay, now I have already told you brainstorming, I told you NGT, I told you fishbone diagram. Fishbone diagram is also called as Ishikawa diagram. I believe you know this. This diagram is also called as cause and effect diagram. We are going to learn DOE today. However, to reach to DOE level, you must have all these tools through with you. You must have done these tools. Then we can move to DOE. Now, we will move ahead to DOE, certain basic terms dedicated to DOE. Look at this. A term called as a trial and run. So trial and run means experiment. Experiment means a particular setting of X factors and making an actual production. That is called as an experiment. Actual production for a trial purpose. Now, this DOE has got several trials and runs. Now, in a design of experiment, we have to first prepare experimental design. How this experimental design is to be prepared, we are now going to learn. Let me take one example of Tejraj Automation, a company here in my place. Look, a company is having a drilling job. There is a job undergoing a drilling operation. There is a drill. This drill moves inside and makes a hole inside the job. Now, for a drilling operation, I am going to consider two governing factors, controllable factors. One is speed, another is speed. I am putting a range of speed 800 to 1000, while the range of speed is given here. Only two levels I am considering, 800 and 1000, only two levels. Now, let's make one table. In the table, I have put these levels of speed, 800 as well 1000. I have also put a level of speeds, 0.04, 0.2, etc. Now, in this table, I have made unique combinations of speeds and feeds. There would be maximum 4 combinations, not more than 4 combinations, if there are two factors at two levels. Now, I am going to make this table. Now, making this table is called as making a experimentation table for design of experiment. Now, this speed 800 is termed as minus. 1000 is termed as plus in our design of experiment language. This 0.04 is termed as minus. 0.2 will be termed as plus in our design of experiment language. So with this, what would be a minus and plus signs seen in the table? It will be minus, plus here, and it will be minus, plus here. Well, now, you may have three factors. If there are three factors at two levels each, then you have how many combinations? You will have 8 combinations. What would be these combinations? These combinations would be like this. Minus, plus, minus, plus, minus, plus, minus, plus, minus, minus, plus, plus, minus, minus, plus, plus, minus, 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 plus, 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 plus. Now look here. How many runs would be there? L raised to x. L are number of levels and x are the factors. Now, we are considering all factors together. So therefore, this is called as a multi-factor at a time, MFAT experiment. Our regression analysis, our scatter diagram is called as OFAT experiment, one factor at a time. Right? Okay. Now, look here. As the number of factors and levels increase, the complexity of experiment increases exponentially. 2 raised to 2, 3 raised to 3. So complexity increases exponentially. So now, with all combinations are performed, then experiments are called as full factorial experiment. Now here, Bhavati has made 16 combinations. So all these 16 combinations are done in actual practice in your company, and you work all the 16 calculations, you write down the value, that is will be called as a full factorial experiment. Aspects of DOE. DOE needs a numerical or attribute data for X factors. Always you must have numerical or attribute data for X factors. That will do. However, for Y factors, you should have numerical data only for DOE. I am putting this whiteboard also in case any explanation required. See, we did one project with ARD. You know, ARD is a defense organization. They prepare microstrip antenna. Microstrip antenna is the antenna for remote location. This antenna passes different waves, and these waves are there in the battle for our army. So they wanted to reduce the size of this antenna. Now, the very first proceed to do your project, the very first thing is you have to identify pain area. This pain area is called as business case. Now, business case is a financial impact. Look over here. It takes around 2 hours to erect this antenna at the site. And this is objectionable for our army. They want antenna to be erected in a lesser amount of time. Now, where is the opportunity for this particular pain area? The opportunity is you have this opportunity for this antenna are enormous. This is every battlefield. Now look at the problem statement. In every project, whenever I advise you, whenever you proceed to a project, you prepare your goal statement in the very beginning. Look at this goal statement. To develop a microstrip antenna with a size reduction by 50%. I have given a goal statement, a single line. There is no any other chatter over here. A specific goal statement. This goal statement is called as SMART statement. SMART stands for specific, measurable, achievable, realistic, time bound. What is the beauty of putting up this SMART goal statement? The beauty is when you put this statement, people will not deviate ahead. They will not deviate across. They will have a constant goal to achieve the reduction by 50%. Now, look here, this is called as affinity diagram. In the very beginning, we did this diagram. In the diagram, we wanted to understand different material available for antenna. Also, we wanted to understand what different sizes are available in the antenna currently. As well, we wanted to know efficiency parameters. Now, as I said you yesterday, this is a funnel of X factors. You have to shorten these X factors. So, you know, when we started this project, we were having 22 X factors. All these X factors were revealed through FMEA, brainstorming, and past data survey and analysis. Then we did brainstorming again. Then we did brainstorming again. We reduced down these factors from 22 to 14. Till this moment, there is no DOE. There is no DOE. Now, a cause and effect matrix is performed to analyze importance rating of these X factors. So I will show you how this cause and effect matrix. Look here. What we did, we wrote a requirements from antenna in the left hand side. Return loss, frequency, time of installation. We wrote a priority. of these requirements. 5 is the highest priority, 1 is the lowest priority. In accordance with this priority, we are going to analyze further. Now, for achieving particular requirement in our product, we have certain design attributes with us. Design attributes are technical specifications, which designer know, customer may not know. So we have written 8 design attributes. Why we wrote only 8 design attributes? Because other design attributes are having negligible rating. Now, these 8 design attributes are now analyzed. Here we have written correlation coefficient. I will tell you how this correlation coefficient is written. Look at the first design attribute, length of patch. Analyze the relationship with return loss. This relationship is put here 1. 1 means very good relation. Look over here. The relationship is a 0.5. So 0.5 is a 50% relation. Look here, it's written 0.1. So 0.1 is almost no relation. So these relation values are to be described. Now, after writing relation values, then you do multiplication. This with this, this with this, this with this. And then make addition. Then write this importance rating. Now, you know, for achieving this requirement of customer, you are going to employ this design attribute, first one, having a highest rating. You are going to focus your attention. You are going to work for this first design attribute. Followed with this one, second one. Followed with this, fifth one. So this way, you can set a sequence for you. Now, you know, do you remember earlier we had 22 alternatives? These 22 were reduced to 14. These 14 were reduced to 8. Now these 8 are reduced to 3. Which 3? First, second, and fifth. This, and this. Now, yes. Now these 3, you can use your conventional DOE practice we saw yesterday. Now these 3 are taken. Now how these 3 are considered ahead? First of all, they're having highest importance rating. Now look here, frequency has highest priority rating. We need frequency to be maintained at constant level, 2.4 gigahertz, with 0.1 gigahertz tolerance in positive side. Now look here, DOE to be performed for evaluating the effect on frequency from these top 3 vital parameters. We need from this design a frequency to be maintained. For maintaining a frequency, we have 3 vital parameters with us. Frequency required to be maintained at constant level 2.4 gigahertz. However, there is a variation in a positive side is allowed.